Yeah, hello viewers, welcome to my channel. So in today's video, we have this Olympiad mathematics question. So we say 2 raised to the power of x plus 3x is equal to 10. So we have to solve for all values of x, alright? So how do we solve for all values of x in this kind of equation? Now, look at this equation. It actually looks somehow, isn't it? Yeah, but we can actually solve this problem easily. Are we together now? So if you are new to this channel, don't forget to subscribe, don't forget to like and comment, and also share. And subscribe and click the notification button so that anytime I upload video, you'll be the first to watch. So how do you find all values of this particular equation? So I'm going to find the integer value and then other values, alright? So that's what I'm going to do. So now let's get started, guys. The first thing we are going to do now for us to find the integer values is to, make a substitution. So what kind of substitution are we making here? So we can say that, let these 2 raised to the power of x be equal to n letter you want to make use of, or any variable. Alright, so let's make sure what lambda, right? So let's 2 raised to the power of x be equal to lambda. So if 2 raised to the power of x is equal to lambda, we have to make x the subject of the formula. And how do we do that? We have to take the natural log of both sides. So we take the natural log of both sides, we have natural log of 2 raised to the power of x is equal to natural log of lambda. Then according to the law of logarithm, so bring your x here. So we're going to have x multiplied by natural log of 2 is equal to natural log of lambda. And then how do you make x the subject of the formula? You have to divide through by natural log of 2. So we have x is equal to natural log of lambda over natural log of 2. That is beautiful. Are we together now? So since we have our x, which is natural log of lambda over natural log of 2, so we cannot substitute everything here into this our original equation. So 2 raised to the power of x, which is lambda, so we have lambda, then plus 3 multiplied by x, which is now what? Natural log of lambda over natural log of 2. Okay, then everything is equal to 10. Now, my aim is to write natural log of lambda. Like, I want it to be on its own. It is my what? Left hand side. Okay, so I want to isolate natural log of lambda. So how can I isolate natural log of lambda in this particular equation? Now the first thing I'm going to do is to subtract lambda from both sides. So if you do that, we have 3 multiplied by natural log of lambda over natural log of 2, so which is equal to 10 minus lambda. The next thing you are going to do is what? You multiply both sides by natural log of 2 over 3. So if we do that, we have natural log of 2 over 3, then multiply by 3 multiplied by natural log of lambda over natural log of 2. So it's equal to 10 minus lambda multiplied by natural log of 2 over 3. So 3 cancel out 3, natural log of 2 cancel out natural log of 2. So what you have now is natural log of lambda is equal to, so you have to open this bracket, 10 multiplied by natural log of 2 over 3, so that will give us, 10 over 3 multiplied by natural log of 2. Then minus, now lambda multiplied by natural log of 2 over 3 will give us what? We have lambda over 3, then multiplied by natural log of 2. Alright, then the next thing you are going to take is to take the exponent of both sides. That is the base of your natural log. So if you do that, we are going to have lambda is equal to, so you apply the law of indices right here. So if you apply the law of indices, you're going to have e raised to the power of 10 over 3 multiplied by natural log of 2. So multiplied by e raised to the power of negative lambda over 3 multiplied by natural log of 2. Right. So that's cool. Now remember that if you have e raised to the power of a natural log of b, so this will surely give us b raised to the power of a. So exponential 10 over 3 multiplied by natural log of 2, so that will give us what? 2 raised to the power of 10 over 3. Are we together? Alright guys, now let's move on. So we are going to have, so lambda, which is now equal to 2 raised to the power of 10 over 3, then multiplied by exponential negative lambda over 3 multiplied by natural log of 2. Now, next thing I want to do now is to isolate 2 raised to the power of 10 over 3. So how can I isolate 2 raised to the power of 10 over 3? So I have to multiply both sides by what? Exponential lambda over 3 multiplied by natural log of 2. So if you do that, we are going to have, lambda multiplied by exponential lambda over 3 multiplied by natural log of 2. So which is now equal to 2 raised to the power of 10 over 3 multiplied by exponential negative lambda over 3 multiplied by natural log of 2. Then multiplied by exponential lambda over 3 multiplied by natural log of 2. Alright, so exponential negative lambda over 3 multiplied by natural log of 2 multiplied by exponential lambda over 3 multiplied by natural log of 2. We have a raised to the power of negative b plus a raised to the power of b. So this means a raised to the power of minus b plus b. So which is a raised to the power of 0. And then any number raised to the power of 0 will give us 1. So that shows that this guy multiplied by this guy will definitely give us 1. Are we together now? Alright, now let's move on. So since we got 1 here, so therefore we're going to have the following. So we're going to have lambda multiplied by exponential lambda over 3 multiplied by natural log of 2. So which is now equal to 2 raised to the power of 10 over 3. Now, look at this. You'll be thinking that this is getting more complicated. Is it? No, it's not. Alright? So we're going to make use of the Lambert W function, or you call it the product log. Alright? So the Lambert W function states that. So we have this kind of function. We have alpha multiplied by exponential alpha, and you take the Lambert W function of this. Alright? So this will surely give us alpha. Okay? So I'm sure you cannot be taught this in school. Alright? So you can only learn this, like if you're a learner or you're a reader, so you can only come across this online, this particular method. So the Lambert W function says that if you have omega of alpha multiplied by e raised to the power of alpha, so definitely this will give us alpha. So that's what I want to make use of here. So I want this and this to have same thing. Alright, so I want to equate this and this to be equal. I want to make them to be equal. So how can I make this and this to be equal? Now I have lambda already, I have lambda, but here I have lambda over 3 multiplied by natural log of 2. So what do you think we can do? So this is what we are going to do. So we are going to multiply both sides, alright, by 1 over 3 multiplied by natural log of 2. So that this and this we have the same what function. So if you do that, we're going to have lambda over 3 multiplied by natural log of 2 and multiplied by exponential lambda over 3 multiplied by natural log of 2, so which is equal to 2 raised to the power of 10 over 3 multiplied by what? 1 over 3 multiplied by natural log of 2. Do you understand now? So I've multiplied both sides by 1 over 3 multiplied by natural log of 2. Then I cannot take the what? The Lambert W function on both sides. So take the omega function of both sides. So omega function of both sides, or lambda, or some call it product rule. Alright? So according to the Lambert W function, I told you that I say we have Lambert W function of alpha multiplied by exponential alpha. I said it's going to give you alpha. So where is your alpha? Do you understand now? So definitely this will give us what? Lambda over 3 multiplied by natural log of 2. So this implies that we have lambda over 3 multiplied by natural log of 2 is equal to W of. Now, how do we simplify this? That is where the problem lies. How do you simplify this? Now, this is what you're going to do. We have 2 raised to the power of 10 over 3. So this means that, 10 is 5 multiplied by 2. So we have 2 raised to the power of 2, then raised to the power of 5, then everything over 3. 2 times 5 will give us 10, right? Then multiply by 1 over 3, multiply by natural log of 2. Are we together now? So 2 raised to the power of 2 will give us 4. Take note of that. So we have 4 raised to the power of 5 over 3. Okay, so don't forget the Lambert W function. So we have 4 raised to the power of 5 over 3. Then multiply by 1 over 3 multiplied by natural log of 2. And then remember that 5 is equal to 5 is equal to 2 plus 3. So the reason I'm using 2 plus 3 is that my denominator here is 3. So I can say that 5 is also 2 plus 3. Alright? So this will be equal to the Lambert W function of 4 raised to the power of 2 then plus 3. Then everything here over 3. Alright? So then multiply by 1 over 3 multiply by natural log of 2. This is cool. So we have Lambert W function of 4 you can apply the linearity right here. So we apply the linearity, we have 4 raised to the power of 2 over 3, then multiply by, plus 3 over 3, then multiply by 1 over 3, multiply by natural log of 2. Now, 3 over 3 will give us what? 1. So therefore, we're going to have Lambert W function of 4, then raised to the power of 2 over 3. We can apply the opposite right here. So that will be 4 raised to the power of what? 3 over 3 will give us 1. So we have multiply by 4 raised to the power of 1. So multiply by 1 over 3, multiply by natural log of 2. That is cool. So this will be equal to Lambert W function of 4 raised to the power of 2 over 3. Then multiply by, now 4 times 1 will give us 4. So you have 4 over 3 multiply by natural log of 2. So actually we can now rewrite 4 raised to the power of 2 over 3 in what? In exponential form. So this will give us Lambert W function of exponential natural log of what? 4 raised to the power of 2 over 3. So you can bring out this 2 over 3. Okay, so we have 4 over 3 natural log of 2 here also. So if I bring out this 2 over 3, so I'm going to have Lambert W function of exponential 2 over 3 multiplied by natural log of 4. Then multiplied by what? 4 over 3 multiplied by natural log of 2. But don't forget, I want this and this to be equal. This thing in the exponent must be equal to this. But this is length 4, which also means length 2 squared. Are we together? So which also means length 2 squared. Length 2 squared. So this will be equal to, alright, I think I will need to clean these parts. Yeah, let me just clean these parts. Okay, now let's move on. So let's continue it here. So I'm going to have Lambert W function of e raised to the power of 2 over 3 length 2 squared, because 4 will give us 2 squared. Then multiply by 4 over 3 multiply by natural log of 2. Alright, so we can now bring this to here. So we have Lambert W function of what? 2 times 2, which is 4, then over 3, exponential 4 over 3 multiplied by natural log of 2, then multiply by 4 over 3 multiplied by natural log of 2. You can see they have same stuff now. So definitely this will be equal to what? 4 over 3 multiplied by natural log of 2. Are we together? So then we have this guy. So then we have lambda over 3 multiplied by natural log of 2. So it's now equal to what? 4 over 3 multiplied by natural log of 2. This is cool. Alright, now don't forget you want to find what? You want to find lambda. So what are we going to do? So this is what we're going to do now. So let's multiply both sides by 3 over natural log of 2. So we have lambda over 3 multiplied by natural log of 2, then multiply by what? 3 over natural log of 2. So which is now equal to 4 over 3 multiplied by natural log of 2, multiplied by what? 3 over natural log of 2. So 3 will cancel out 3. Alright, so natural log of 2 will cancel out natural log of 2. And then here also, natural log of 2 will cancel out natural log of 2. 3 will cancel out 3. So we have lambda is equal to 4. So the value of lambda is now 4. The value of lambda is 4. But don't forget, you want to find the value of x, okay? But remember that 2 raised to the power of x is equal to lambda. And then we have lambda to be 4. So we have 2 raised to the power of x is equal to 4. And we know 4 is what? 2 raised to the power of 2. So we have 2 raised to the power of x is equal to 2 raised to the power of 2. And definitely we equate the exponents, or you compare the exponents. So we have x is equal to 2. So that's the only integer value that we have. Okay? So we input x here to be 2. We're going to have 2 squared plus 3 into bracket 2. So 2 squared will give us 4. And 3 multiplied by 2 will give us 6. So 4 plus 6 will give us what? 10. We can say we have our 10. Alright? So that is the only integer value we have. Alright, what if we are asked to find other values of x? Other values of x. So how do we do that? How do we find the other values of x? Now, you're going to do it this way. You're going to do that this way. Don't forget, as you are watching, don't forget to subscribe to my channel. Don't forget to like the video. Don't forget to comment. If you understand, say yes, I understand. Okay, don't forget to share. All right. Now, here is the other method round. We want to do it. So we have 2 raised to the power of x plus 3x is equal to 10. So how are we going to do this? So this is what we are going to do. We can actually subtract 3x from both sides. So if we do that, we're going to have 2 raised to the power of x is equal to 10 minus 3x. Are we together? So then after that, we have 2 raised to the power of x here, which is equal to 10 minus 3x. So what we can do next? So what we are going to do now is to, divide through by 2 raised to the power of x. So if I do that, I'm going to have 2 raised to the power of x, alright, divided by 2 raised to the power of x. Okay, so or the same multiply by 2 by 2 raised to the power of negative x. 2 raised to the power of negative x. So which is equal to 10 minus 3x multiplied by 2 raised to the power of negative x. So 2 raised to the power of x multiplied by 2 raised to the power of negative x will give us what? That will give us 1. Alright? So we have 1 is equal to 10 minus 3x multiplied by 2 raised to the power of negative x. So this is cool. So what do you think we can do next? Now, this is negative 3x and this is 2 raised to the power of negative x. So that's where the problem is coming from. So what do you think we can actually do here to solve the problem correctly without any error? Without us doing any error. Now, this is 2 raised to the power of negative x and this is negative 3x. Okay. Alright, now let's do it this way around. Okay, so we want to solve this problem. So how are we going to solve it? Yeah. Other way around, this is how you do that. So we have 2 raised to the power of x plus 3x is equal to 10. So what do you think we can do? So the first thing we are going to do is to what you divide through by 3. So we divide through by 3, we're going to have 2 raised to the power of x over 3. Okay, so plus x is equal to 10 over 3. Alright, so we have 2 raised to the power of x over 3 is equal to plus x is equal to 10 over 3. Alright, the next thing you're going to do is to subtract x from both sides. So we have 2 raised to the power of x over 3 is equal to 10 over 3, then minus x. So what will be the next thing we are going to do? The next thing we are going to do is to divide through by 2 raised to the power of x. So we do that, or you multiply both sides by 2 raised to the power of negative x. So we're going to have 2 raised to the power of x over 3 multiplied by 2 raised to the power of negative x. It's equal to 10 over 3 minus x multiplied by 2 raised to the power of negative x. Okay? So 2 raised to the power of x multiplied by 2 raised to the power of negative x will actually give us 1. So we have 1 over 3 is equal to 10 over 3 minus x, then multiplied by 2 raised to the power of negative x. Now, next thing we are going to do is to, I want this guy to be the same thing as this guy. So what do you think I can do? I can multiply both sides by what? 2 raised to the power of 10 over 3. So if I do that, I'm going to have 1 over 3 multiplied by 2 raised to the power of 10 over 3. Okay, so which is now equal to 10 over 3 minus x multiplied by 2 raised to the power of negative x multiplied by 2 raised to the power of 10 over 3. So this will give us 1 over 3 multiplied by 2 raised to the power of 10 over 3. So which is now equal to, 2 raised to the power of negative x multiplied by 2 raised to the power of 10 over 3. That will give us 10 over 3 minus x, then multiplied by 2 raised to the power of what? 10 over 3 minus x. So we can now rewrite 2 raised to the power of 10 over 3 minus x as follows. So we're going to have 1 over 3 multiplied by 2 raised to the power of 10 over 3. So which is now equal to 10 over 3, okay, minus x, then multiplied by exponential, 10 over 3 minus x, then multiplied by natural log of 2. But look at this exponent, I'm having natural log of 2, and here I'm not having natural log of 2. So I have to multiply both sides by natural log of 2. So I'm going to have, natural log of 2 over 3 multiplied by 2 raised to the power of 10 over 3. Okay, so which is equal to 10 over 3 minus s multiplied by natural log of 2, then multiplied by exponential 10 over 3 minus x multiplied by natural log of 2. So we can now take the Lambert W function on both sides. Okay, so we take the Lambert W function on both sides. So what are we going to have? So we're going to have Lambert W function of natural log of 2 over 3 multiplied by 2 raised to the power of 10 over 3. So which is equal to Lambert W function of 10 over 3 minus x, then multiplied by natural log of 2, then multiplied by exponential 10 over 3 minus x multiplied by natural log of 2. Are we together now? So let's clean this part. Good. So therefore, this and this guy, they cancel out. So what you have now is 10 over 3 minus x, then multiplied by natural log of 2 is equal to, if you take the Lambert W function of this, so what did we got the other time? I think we got 4 over 3 multiplied by natural log of 2. Are we together? But in some cases, alright, so this is, we have two major branches. We have the principal branch and we have the branch cut. Are we together? We have two major branches. We have the principal branch and the branch cut. Alright, so let's just put k here. So where k is what set of integers. Are we together now? So when you put k to be 0, that's when you have what? The principal branch, alright? So the principal value. So that's why we have 4 over 3 multiplied by natural log of 2. Alright, so then we have 10 over 3 minus x. If you divide through by natural log of 2, so which is now equal to 4 over 3. Then subtract 10 over 3 from both sides. We have negative x is equal to 4 over 3 minus 10 over 3. So we have negative x is equal to what? So the LCM is 3, so we have 4 minus 10. Alright? So we have negative x is equal to negative 6 over 3. And negative 6 over 3 will give us negative 2. So we have negative x is equal to negative 2. So we have x is equal to 2. Alright, the only integer value of x is what? 2. Now you see we got the same answer with the first solution. Alright, but for other values, so I already say that you're going to have the Lambert W function base k, subscript k of natural log of 2 over 3 multiplied by 2 raised to the power of 10 over 3, right? So when k is a principal value, we got the value of our x here. Then when it is a branch cut, you get, is either you got decimal or you got complex number. Are we together? So this k is set of integers, so we have a numerous answer. A lot of answer can what fit into this. So it depends on the value of k. So when k is 0, that is why we have 2, and that is where I'm going to stop. Alright guys, so if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment and also share. Thanks for watching. See you next time. Bye.